Hey future Gate toppers, welcome back to ShortGATE. Today we are diving into Heap Sort, a sorting algorithm with a twist. Imagine you are organizing a huge pile of stones. You want to pull the biggest stones one, but instead of looking through the whole pile every time, you have arranged them in a clever pyramid shape. Sounds cool, right? That's pretty much what Heap Sort does with your data. It builds a heap and sorts it layer by layer. Stick around as we break it down step by step and make Heap Sort your new best friend in sorting. What is heap? A heap is a specialized binary tree data structure that specifies the heap property. In a max heap, for any given node I, the value of I is greater than or equal to the value of its children. In a min heap, the value of I is smaller than or equal to its children. Heap sort uses a max heap to sort the array. So, the largest element always rises to the top. Now see, what is heap sort? Heap sort is a comparison-based sorting algorithm that uses a binary heap data structures to efficiently sort an array. It builds a max heap, repeatedly extracts the largest element and places it at the end of the array. This process continues until the entire array is sorted. Unlike quicksort, heapsort has a guaranteed time complexity of order of n log n in all cases. Now see, how does heapsort work? Here's a step-by-step breakdown of heapsort. First, build a max heap, then extract the largest element, then heapify the root, then repeat the entire process until the array is sorted. Now how build a max heap? Convert the array into a max heap whether the largest element is at the root. Swap the root, the largest element, with the last element of the array and reduce the heap size by 1. Ensure the heap property is maintained by recursively heapifying the root element. Continue extracting the largest element and heapifying the root until the heap size becomes 1. The array will now be sorted. Now see an example. 77, 15, 91, 21, 6, 46. Sort using heap sort. Build a max heap. After heapifying, the array becomes 91, 21, 77, 15, 6 and 46. Then extract 91. Swap 91 with the first element, that is 46, resulting in 46, 21, 77, 15, 6 and 91. Heapifying the root, resulting in this array. Extract 77. Then swap 77 with 6. Continue extracting and heapifying until the array is sorted. Now see the time complexity. One of the strengths of heapsort is its guaranteed order of n log n time complexity, regardless of the input. Here's how it breaks down. The best case, average case and worst case time complexity of heapsort is order of n log n. Heapsort is a reliable sorting algorithm for large datasets due to its consistent performance. Now see the advantages and disadvantages of heapsort. What are the advantages? It is consistent order of n log n time complexity in all cases. In place of sorting algorithm. Require no extra memory. Work well for large datasets where memory is limited. What are the disadvantages? Not stable sort. Does not preserve the relative order of equal elements. Typically slower than quicksort in practice for smaller datasets. Let's now look at how implement heapsort. We will first write the functions to build a max heap and then we will implement the sorting algorithm. And just like that, you are mastered heapsort. I hope you found this deep dive helpful. Heapsort may not be as flashy as quicksort, but it's rock solid with its consistent order of n log n performance, making it a sorting powerhouse, especially for large datasets. Before you go, don't forget to click the like button. If this video cleared up heapsort for you, subscribe to ShortGATE for more Gate CS topics and tricks. And let me know in the comment if there's another algorithm or topic you are curious about. Remember, each algorithm is like a tool in your GATE kit, and understanding their strengths and weaknesses is key to cracking GATE. Keep practicing, stay curious, and as always, happy learning.